Hello, I am Hyundai Kim from Turing Corporation. I will demonstrate our research work leveraging skill-to-skill supervision for knowledge tracing on behalf of our gorgeous and excellent co-authors, Jinwoo Nam, Minjae Lee, Jegal, and Kyungwoo Song. As you may know, this has been a huge changes in our education system due to the pandemic. Offline classes were limited due to social distancing. Online classes replaced the traditional face-to-face classrooms. Demands on online education platform and intelligent tutoring system is increasing. The educational gap increased larger due to the limited access to the educational resources. We are facing a huge change in our education system. As we know, the knowledge tracing plays an important role on intelligent tutoring system. Our research begins with following research question. What if we can get the ground truth dependency graph from human experts? Can we improve the performance by human-level graph? Also, data sparsity is a well-known issue on many AI education datasets. It may be very hard to determine the relationship between knowledge confidence from sparse data. Also, we may not be able to ensure the dependency relationship from our trained knowledge tracing model is correct. Thus, we need to we need the ground truth relationship to cope with all the challenges. We propose supervision by human knowledge on skill relationship on deep learning based KT model. We provide annotated relationships of knowledge to components. Also, we propose novel deep learning approaches to leverage such humans knowledge into deep knowledge tracing. First, let me get into the details of annotation. To focus on the OCS germline dataset, which is one of the most widely used dataset on knowledge tracing. It contains more than 500,000 of liquids and 110 knowledge components. We recruited 4 human experts to annotate the relationship between knowledge components. All of the experts hold related careers such as math instructor or math teacher or related degree like math education or math. We assume that the skill-to-skill relationship from the experts to covers idea is the ground truth. The figure A illustrates the way how each expert annotated the relationships between the knowledge components. Each expert has many different ideas. Thus, we let the expert to annotate the relationships individually first at the first time. Then we made the expert to have meetings in order to determine these final relationships. The figure B demonstrates the way how build the vectorized representations from the expert's technology. Now let's go into methodology. We use transformer, which is widely used in various areas such as sequential prediction, image processing, and NLP. To improve the effectiveness of our transform method, we use a method called NoteVec to obtain vectorized representation of knowledge components or knowledge skills. These vectorized representations allow us to better understand the relationship between each knowledge components. Before we input the vectorized representations of knowledge components into the transform model, first of all, we train the vectors using projection laws architecture. After that, we use those vectors um, put into the encoders. And for transform decoder, we made another vector sequence using skill index and criteria. By this, our model can utilize information from students' previous performance, the students' problem solving history. This is the general framework of our proposed model. First, we obtain the knowledge graph from the human explicit annotation. So in this case, we use the coverage tools version. So all of the experts involved into the building the relationship between the each knowledge components. Then we train node to back based on that graph to attain the skill to back vectors. After that, we use projection layer to train new problem embeddings, which will go into knowledge tracing models encoder input. The new problem embeddings, P5Is, are expected to gain skill inherent information here, in addition to skill relationship information. Finally, we include new problem embeddings and learning history with correctness into our knowledge tracing model in order to predict students' correctness on other problems. Now, let's move on to results and discussions. For the dataset, as we mentioned above, we use OCS 9. We train our model on the 90% of the datasets with following hyperparameters such as 25 dimension for node to back and 200 epochs, 512 batch size, single head, 4 layer, and 4 decoder transformer. The results is very promising and shows the effectiveness of our model and proposed methods. All of the methods improves the performance compared to the baseline transformer model, which does not use the protection laws and or the mass expresses the domain knowledge. We observed the we observed that a skill to factor and the node to back representation from the express domain knowledge improves the performance, especially on pure shot test and in small data set. Furthermore, we confirmed that our model performs better than the model that use random skill-to-skill relationship graph from our experiments. This fact tells us that also proves that we can utilize insight in human domain knowledge to predict the future behavior in other sequential data or other knowledge tracing tasks. If so, our methodology is quite applicable in many tasks and not only on knowledge tracing. To conclude, we confirmed that humans domain knowledge, especially high quality knowledge, can improve the performance of deep learning based knowledge tracing model in this work. Our methods such as skill to bag or projection rules architecture not only can be applied to the other researches, but also improve the performance on assisted online quite significantly. To the best of our knowledge, we firstly open skill to skill relationship on OCS Online dataset, which are annotated by human experts. Our work can be utilized to other AI edu researches on OCS Online dataset or other mass domain datasets. We strongly believe that our work can contribute to other researchers and such as improving who is working on such as improving the performance of knowledge tracing or the interpretability of educational AI. You can check out our code repository on the following URL in order to get the such a relationship of the OSHIS 9 or our code. If you have any question, you can just ask us directly in the discussion forum. Also, you can send us email if you have any inquiries. Thank you so much.